and welcome to the third lesson for the theory for junction design. Now today we are going to be talking about an introduction to how do you design these auxiliary lanes. Remember we talked about the functional area and we also talked about the auxiliary lanes. So what do you consider? Remember the auxiliary lanes determine the length and how far back the junction can span. As you noted in our example, you can see these auxiliary lanes are much higher. I mean, here we have a U-turn, we have a number of things in the area. So what are some of the design considerations? So you shall find that normally they are used at medians or before left and right turns, which we mentioned earlier. And the goal is you want to reduce crashes and increase capacity at the junction, mainly when you do this. And you shall find that normally they are at least 3 meters wide and 1.8 meter shoulders. Now there are cases where you will not have a shoulder. Okay, this 1.8, there are cases where we just provide shoulders of 0.5 meters. If you have in an urban area where you have constraints. But if you don't have the shoulders as 1.8 meters, and you can find most of cases, they always include acceleration or deceleration lanes. Now we are going to really talk about this as we further go on. So what are desirably we would want an auxiliary lane to compose of 3 parts. Normally D1, D2, and D3. So what's D1? D1, you want to make sure there's something we call the lane change and perception reaction time, which is D1. We have the deceleration lane and the storage lane. Okay? So someone is coming and they need a perception reaction time. So from the start here all the way to here, this vehicle is perceiving something. It's understanding, oh, there could be a junction in that area. And that's the perception. And we're going to go further. What are the distances you consider regarding this? What should you consider? Then the next is D2. Okay? D2 has 2 components. So we have something we call clear through lane and complete lane change. So we're looking at the time it takes a vehicle to make one to perceive, start making that change, and finally making that change. And that's why if you remember what we're looking at as D2 is we're looking at it can either be, in this case, deceleration lane. What you need for someone to make that maneuver to switch and then have a complete lane change. Now after someone has made this decision, okay, so we look at the final one, which is now the storage, which is D3. If someone has made that lane and now you're going to store up a number of cars. This concept is very important. And this is what normally traffic affects. You may find yourself in situations where they ask you, hey, can you increase the storage length, let's say from 60 meters, which can be roughly, you find that in most cases, can be around 190 feet. So they tell you, oh, we need you to change it from 190 feet to maybe 250 feet or 220 feet. And you have to go back and change. And then they're like, oh, we think at the clear through lane, the taper is not enough. Make sure it's, rather than a 1 in 8, maybe make sure it's a 1 in 10, 1 in 11, based on the junction you have. And you're going to find that these are the 3 parameters we play around with. So in the next 3 lessons, we are going to look at what are the considerations for each of these. What do you consider for the perception? What do you consider for the length through change? And finally, what do you consider for the storage length? Now for the storage length, having a very good idea is guided by the traffic, which you can find in the traffic design course.